Today I'll discuss heat exchangers, specifically flows in heat exchangers, i.e. exchangers operating in parallel flow or countercurrent flow during heat transfer. What does it mean and what changes? What does it mean? Let's say that the word itself says it. A countercurrent heat exchanger involves the exchange of energy between two fluids, facilitating the transfer of heat to each other as they circulate inside the exchanger in opposite directions, thereby maximizing efficiency and minimizing heat loss. Now, if in a plate heat exchanger it is quite simple to understand, that is, one fluid flows down from the top, the other fluid flows up from the bottom. In a single pass shell and tube heat exchanger, this discussion is equally simple because we have a shell in which the fluid flows, let's say, in one direction, and in the tubes the other fluid flows in the opposite direction. This flow arrangement allows for efficient heat transfer between the two fluids, maximizing the exchange of thermal energy. It is clear that with a multipass heat exchanger, it becomes more complex to understand. In an air heat exchanger or in a finned pack heat exchanger, the concept is also simple to understand. We have the airflow flowing in the opposite direction of the water flow. Equicurrent is exactly the opposite operation, meaning that both fluids flow in the same direction instead of flowing in opposite directions. What alterations and why is one method employed instead of another? What alterations? It is quite evident. Let's assume that a counterflow heat exchanger enables higher heat exchange efficiency, indicating that it permits the outlet temperature of a fluid to be in close proximity to the inlet temperature of the opposite fluid, both during heating and cooling processes. I'm not here to talk to you about temperatures because it's obvious that it works in both cases. In plate heat exchangers, however, this particular type of countercurrent exchange also facilitates the crossing of temperatures. The temperature cross is evidently allowed in all other types of exchangers with different efficiency coefficients, and therefore with different thermal yields depending on the type of exchanger. So depending on the exchange coefficients, the type of exchanger, but this is not the subject of this video, also because we have already extensively discussed it on other occasions. Equicurrent evidently does not allow a crossing of temperatures for obvious reasons, because the two temperatures will tend to approach each other from the starting point to the end point. When do you use it? When, for example, we need to do cooling or heating, or let's say thermal exchanges that are a bit softer, that is less drastic, less invasive, less thermodynamically impactful for the fluid that needs to be cooled or heated, for instance, in situations where a more gentle approach is required. Why this? For instance, heat exchanges in pharmaceutical or food sectors require a thermal scheme that avoids shocks to the cooled or heated product, preventing alteration and preserving its intended use. This is the fundamental distinction. If it's unclear, please comment. Have a good day, everyone, and thank you.